Hello everyone, welcome to this class. This class will be all about differential equations. So specifically, we're going to be talking about first order, okay? So first order differential equations, these things, all this means right here, first order, is you're going to have to know what order is just a derivative. It's the first derivative. So I'm talking about y prime or dy dx, or it goes by different names, but the first derivative, you have to know what that is. So if you do not know what that is, I recommend going and taking a look at one of the previous videos and taking a look at one of the more pre-calc classes that I have, once again, for free on the channel. Just go ahead, go look for it. But go ahead, look at pre-calc, PD vids, pre-calc, and boom, it'll be there. Anyways, how to PD vids, pre-calc, how to take a derivative. It'll be there, what a derivative is and everything. Hold on, hey, what are you doing? Now that you went to that video and now that you understand how to take a derivative and what a derivative is, now you can understand what a first order differential equation is. And now here I'm gonna write up an example of what a first order differential equation may be. So a very basic first order differential equation can look something like this. dy dx equals 2xy, okay? Something like this. This can also be written as y prime equals 2xy, okay? So this right here, this is probably how your question would be asked. Okay, y prime equals 2xy, so solve for it. What is y, pretty much? What does y equal? When it says solve, what is that? Or it's asking for what is y equal, So anyways, dy dx, you can write y prime as dy dx if you know what a derivative is and you know that this is, you know what these mean, okay? So once you do this, this right here is specifically called a separable. This is a separable differential equation. Separable differential equation right here. The reason it's separable is because you can separate it. And the reason why you can separate it is, let me show you how. This is the method of separation right here, okay? What you do is you say, you want to separate the y's on one side and the x's on another, okay? So, I'm going to erase the board and redo it so that y'all can see it better, okay? The first question is dy dx equals 2xy, okay? So what we're going to do here is, the way you separate it is you say, you're going to divide both sides by y. I'll just do both steps at the same, okay? So dy over dx, and we'll just say times y. And then what we'll do is we're going to equals 2x, is we're going to multiply both sides by dx, okay? Actually, yeah, y'all can see the steps though, yeah? Hopefully y'all can see the steps. And then what you're going to do is you're going to see that I'll go like this just so that y'all can see. dy over y equals 2x dx, right? That's how that's going to look, okay? So your equation right here, you're going to integrate, okay? You're just going to go boom and boom. Because what that's going to do is that's going to get rid of your dy's and your dx's, okay? Because you're just going to be summing up all the different, y'all understand how integrals, and so actually if y'all don't understand how integrals work, y'all are going to have to know how those work. But those go along with derivatives though, okay? So, all right. And the reason we're going to need to do this is because we have a y prime. We have a dy dx. That's, in order to get rid of this dy dx, to solve, to say y, or to say y equals, in order to say y equals something, we're going to need to integrate, okay? So after we integrate, we're going to see that we're going to be left with the natural log of the absolute value of y equals, what is that over there? What's the integral of 2x? Well, you're going to get x squared plus, so when you say ln absolute value y equals x squared plus c, because there's going to be a constant that you don't know what it could be. Because the derivative, just to give you a quick check, the derivative of x squared will equal 2x, right? And then the derivative of, say this is 7 right here, right? It's a constant. The derivative of 7, what's that going to be? 0. And so you're not going to know. So that's why you have to put a plus c when you take the integral there. Anyways, once you have this right here, right? How are we going to isolate the y? We're going to have to say, okay, well, yeah, you're going to have to say e. You're going to exponentiate, okay? You're going to exponentiate both sides. So then you say e to that, and then e to that, okay? So then you're going to actually be left with y equals, or the absolute value of y equals c to the x squared plus c, right? Or e to the x squared plus c. And then, those of you that could see, this right here, I'll erase that. This equals e to the x squared times e to the c, right? Because say you had e to the, no, we'll do something simpler. We have 2 to the 2 plus 2, right? What does this equal? This equals 2 to the 4, right? But if you said, like, let's do some math. So this equals 2 to the 4, so that equals 2, 4, 8, 16, right? 16. But if you said 2 times 2 to the 2, right? If you broke it up like that, right? This would equal, what is that? 2, 4. 4 times 4 equals 16. So it's the same. So that's why you can break it up like this here. And then, what is this right here? E to the c. That's just some constant that you can call c out front. So you say c e to the x squared. Now, this c right here can absorb the absolute value bars, because if it's negative, then you could just make that negative and then boom, that'll it'll absorb it. So your answer right here will be y equals c e to the x squared. This will be your answer for question 1. That right there is a simple example of a separable differential equation, and it's separable because, as you can see here, this is your first question. You separate it by taking the y's, putting them on one side, and then the x's and putting them on the other. So you have the y's right here, and then the x's right here. dy over y, 2x dx, right? Integrate them to get this right here, right? Once you get this, you get, or no. You integrate those to get this right here, right? And then to solve this, then you exponentiate both sides. You exponentiate both sides of the equation. Once you do that, then you get this right here, right? And then once you write, this is the correct answer right here, but typically you are supposed to write it like this, because this is going to be a whole lot easier to comprehend than this once you get more advanced. And in a lot of cases, you're going to need to convert it to this, and you'll see why. But yeah. All right. So take a look at our next equation here. As you can see here, e to the x plus y dy minus dx equals 0. All right, here, let's do this a little quicker. So first thing we could do, add dx to both sides. At the same time, you could see here that I'm going to rewrite this as e to the x times e to the y dy equals dx. Okay? And once you do that, let's divide both sides by e to the x. Okay? So we're going to get e. Oh my gosh, that's a terrible dog shit e. What I'm actually going to do is I'm actually going to rewrite it as e to the y dy equals e to the negative x dx. Okay? Reason why, again, not stylistic, but for the purpose of taking the integral. Because when I take the integral of this, you can see that the integral of e to the y dy equals the integral of e to the negative x dx. This is going to equal right here e to the y, because the derivative of e to the y is just e to the y, equals, what's this right here? Negative e to the negative x. Because the derivative of e to the negative x will be e to the negative x times the derivative of negative x, which is negative 1. So this is actually negative 1 times it, but you could just, you know, put the negative sign there. Okay. Now, hey, what do you do next? You have to say plus c, okay? Because there's a constant, you don't know what it could be, you know? Okay? Now what you're going to do is you're going to take the logarithm of both sides, okay? So, the natural log of e to the y equals the natural log of... It's going to equal the natural log of what's in here. Negative this plus that. So what I'm actually going to do is I'm going to rewrite it. No, I'm not going to rewrite it. I'm going to say e to the negative x plus c, okay? And with this right here, what does this equal? This is the exact same thing as y, okay? You have to know that the natural log with base e to the, 4 equals 4. This to the x equals x, okay? This is how it works right here, okay? That's how logarithms work. Go ahead and take a look at my video, PD Maths, logarithms. Go ahead, look at my video on logarithms and go fully understand logarithms and derivatives so that your math classes will be easier so that you'll succeed in life, alright? You're going to get y equals the natural log of... So this right here, this is going to actually be rewritten as c minus, because if I just put the c out front, since it's positive c minus e to the negative x. This is your answer right here, okay? Just e to the negative x as 1 over e to the x, if you wanted, okay? This is the same thing all the way through here. But you wanted to, it's harder to see the negative here in the 1 over e to the x. That's why you have to put, or no, you don't have to, but that's why I put the negative there so that you would see it. All right, here's another example of another differential equation that you already know is separable. I'm telling you it's separable, but in the real world, if you were analyzing something, you could easily have a differential equation that has dy dx in it that if you were to analyze, you can just get. And then you can also see that, oh no. You may think that this is like, oh, this is just numbers right here, but this is definitely used in the real world, like everywhere in the real world. So if you know how to solve this, and if you know how to use your analytical thinking to solve these problems, you'll feel good. Hopefully. I don't know, man. What you're going to need to do here is you're going to need to see and know already that this is a separable differential equation. So you're going to need to put the y's on one side and the x's on another, okay? So first thing we could do is we can add both sides by this, okay? So we got y dx equals x minus 2 dy, okay? Now, what we could also do is we could say, let's divide both sides by y, okay? And divide both sides by x minus 2, okay? So what we're going to get is 1 over x minus 2 dx equals 1 over y dy, okay? Now, as you can see here, if we solve for this, let's integrate both sides, okay? So I'm gonna move the y's to this side, okay? So we're gonna say the integral of 1 over y dy equals the integral of 1 over x minus 2 dx, okay? Now what does this equal right here? This right here is gonna equal the natural log of the absolute value of y equals, what is this right here? This is also the natural log of the absolute value of what's inside there, x minus 2. The reason why that is because what's the derivative of x minus 2? That's just 1, right? So there's no need to put anything else. And then plus c, okay? Now, what do? We're going to exponentiate both sides, okay? Let's exponentiate both sides so that we can isolate the y. So when we isolate the y, we get y equals, if we take e to the natural log of the absolute value of x minus 2 plus c, like that, right? What's going to happen here is you're going to see that you can also, if you have this right here, then you can also see that you can also rewrite this as e to the ln of x minus 2 times e to the c, right? Yeah, no, if you could just see here, this right here, this just equals, this right here will just equal x minus 2, right? And then that constant, that times e to the c, that's just another constant. So then you have c times that. So your answer is just y equals constant times x minus 2. That's your answer right there. The reason why it's not absolute value bars right here is because the constant is going to absorb the absolute value bars when you integrate it. Alright everyone, that's it for this video. Thank you so much for watching. I'm just going to give y'all a quick bonus question just to remind y'all the essence of this video, that when you have a separable differential equation, I just made this up on my mind. It might not even be separable. Let's try it. But when you have a separable equation, first thing you try is moving all the y's on one side and all the x's on another, okay? So what we're going to do, we're going to add, we're going to subtract this from both sides, okay? So we're going to say xy equals dy dx minus 4x, okay? Now what you're going to do is you're going to see that it's not actually separable, okay? The reason is because what's funny is I'm actually editing the video right now. As you can clearly tell, it's later and a different time in the day. But as you can see, I looked it over and it actually is separable. So if I were to redo what my thought process was, I actually can divide everything by x. Let's divide everything by x. So if you divide everything by 1 over x, then you get y equals dy over x dx minus 4, right? Now, if you were to add 4 to both sides, you get y plus 4 equals dy over x dx, okay? Now, what you could do, multiply both sides by x dx. Let's get x dx times y plus 4 equals dy. Divide both sides by y plus 4. Now you get x dx equals dy over y plus 4. Okay? Now you have successfully got all the y's on one side and all the x's on another and separated this separable differential equation. So let's actually solve it. So here we could see that this equals the natural log of y plus 4. What am I doing here? The absolute value of y plus 4 equals, what's the integral of x right here? It's actually 1/2 x squared, and then we're going to have a plus c right here. And then now let's solve for this y right here. Got to exponentiate both sides. Y plus 4 equals e to the 1/2 x squared plus c, okay? Once again, we know that this c right here is actually just, boom, that's that right there, right? Now, let's add 4 to, or subtract 4 from both sides. So y equals c e to the 1/2 x squared minus 4. Would you look at that? We just solved a problem that we made up using separable methods. Separation, solving by separation. But would you look at that? That's how we're going to end this video. And thank you guys again so much for watching. Make sure y'all subscribe and watch the other videos to learn about derivatives, integrals, logarithms, and all that good stuff. And yeah, thank you all again for watching. And we out.